Welcome to my class 12 Physics, chapter that is ray optics, and today we will discuss about sign convention for the spherical mirror. What is sign convention? And generally in case of a spherical mirror, we can measure focal length of the spherical mirror, radius of curvature of the spherical mirror, similarly image distance, object distance. Object distance means distance between pole to the position of the object, that is the object distance. Image distance means distance between the pole to the position of the image, that is the image distance. Similarly, your height of the object and height of the image. Clear? Then which one is positive and which one is negative? And for this sign convention is needed. Clear? So that for sign convention, first we take a Cartesian coordinate system. So for this one is your y-axis and this one is your x-axis. Two axes are there, and we write here, this is the x-axis. For x-axis we write x prime, and for y-axis we write that is y prime, and this point is the origin or starting point. For this we write suppose O is the origin, and right hand side of the x-axis, that is sign is positive, and the left hand side of the x-axis sign is negative. Similarly, above the x-axis means this side of the y-axis, that is positive. Similarly, this side of the y-axis is negative. We know that. Clear? Then pole is there in case of a spherical mirror. In case of a spherical mirror, pole is there. What is pole? We know the center of the reflecting surface of the spherical mirror. Spherical mirror means that may be concave mirror or may be convex mirror, but center of the reflecting surface is known as the pole. And in case of sign convention, pole of the spherical mirror must be coincide with the origin of the Cartesian coordinate system. Clear? And for this, suppose here you draw a concave mirror. And your outer surface is silver coated. Suppose this one is the outer surface. Silver coated means that is the non-reflecting surface. Your outer surface is the non-reflecting surface. And inner surface means this side is known as the reflecting surface. This is the outer surface, that is the non-reflecting surface. Now this is a concave spherical mirror, and this is the reflecting surface. And reflecting surface, this point is the center of the reflecting surface, and the center of the reflecting surface is known as the pole of the concave spherical mirror. Clear? And here pole of the spherical mirror is coincide with the origin of the Cartesian coordinate system. Both are same. Now all distance measured always starting from the pole, that means all the measurement always starting from the pole, just like your Cartesian coordinate system. Clear? And suppose the object is there. Suppose this is the object, and for height of the object, we write that is AB. This point is A, this point is B, this one is the object. Clear? Then we draw the image. For image, first incident ray is there. This is the incident ray, suppose, and here incident ray is parallel to the principal axis, and this is the direction of the incident ray. This is the direction of the incident ray. And suppose image is formed here. Suppose this one is the position of the image. If this one is the position of the image, here image is situated in the downward direction, and for size of the image or height of the image we write suppose that is A1 B1. Clear? Here AB, that is the object, and A1, B1, suppose that is the image, and this one is the incident ray. Incident ray is, its direction is along the positive x-axis, because this is the positive x-axis, this is the direction of the positive x-axis. Then suppose if measurement is in this direction means this is the direction of the incident ray. This is the direction of the incident ray. Suppose we measure the distance. Always starting from pole and in the positive x-axis. If measurement of the distance is done in this direction means this is the direction. If measurement of the distance is just like this, and this is same as direction of the incident ray. Here this is the direction of the incident ray, and suppose distance is measured along this direction, that means both are in the same direction. If both are in the same direction, then this distance gives positive sign. Here sign is positive. Clear? Similarly, suppose if we measure the distance just opposite to the direction of the incident ray, if we measure the distance starting from the pole just opposite to the direction of the incident ray, because this is the direction of the incident ray, and we measure the distance just opposite means in this direction, because always measurement is starting from pole is the starting point, and we measure the distance starting from pole in this direction. Clear? If we measure the distance in this direction, this is the direction of the incident ray. Here both are in the opposite direction. If both are in the opposite direction, sign is negative. If we measure the distance in the same direction of the incident ray, sign is positive. If we measure the distance just opposite to the direction of the incident ray, sign is negative. Clear? Similarly, this is the positive side of the y-axis, and your object is situated above the x-axis, and here also if we take this one is the concave spherical mirror, then this is the principal axis. This one is the principal axis of the concave mirror, because principal axis passing through the pole and also center of the curvature and perpendicular to the reflecting surface at the pole, that. So that this one is the principal axis of the spherical mirror, and here in case of sign convention, principal axis of a spherical mirror coincide with the x-axis. Principal axis of the spherical mirror coincide with the x-axis of the Cartesian coordinate system. Pole of the spherical mirror coincide with the origin of the Cartesian coordinate system. Then here object AB is situated above the principal axis or above the x-axis. If object is situated above the principal axis, always sign is positive. Clear? If object is situated above the principal axis or above the x-axis, always sign is positive. Similarly, this one is the image. Suppose image is situated just below the principal axis. If image is situated just below the principal axis, sign is negative. Below the principal axis, sign is negative. Above the principal axis, sign is positive. Same measurement is in the same direction as the incident ray, sign is positive. Measurement is just opposite to the direction of the incident ray, sign is negative. And this is all about your sign convention for spherical mirror. Clear? And suppose one example. Suppose you take a concave mirror. First a concave mirror is there. Suppose this one is your concave mirror. Here outer surface is silver coated. Suppose this one is your outer surface. and the inner surface is the reflecting surface, so that this is a concave mirror. We write that is concave spherical mirror. And you know this point is the center, this point is the center of the reflecting surface, because this is the reflecting surface, and center of the reflecting surface we write that is pole, and a line is passing through the pole. Suppose you draw a line passing through the pole, and this line is suppose the principal axis, then this point we write that is the focus. For focus we write capital F. This is the center of curvature. For center of curvature we write capital C. And suppose your object is situated outside the center of curvature. This is the object, and your object is perpendicular to the principal axis. Object is perpendicular to the principal axis, and for object we write that is AB. Clear? Then you draw the image for this object, and for this we take two incident rays. This one is the first incident ray parallel to the principal axis, and you know after reflection the ray must be passing through the focus, and this is the reflecting ray, this is the reflected ray. Similarly, another incident ray is there, that moves towards the pole of the spherical mirror, and you know this is the angle of incidence, because at point P, suppose P point is the point of incidence, then you draw a normal, and your normal is the principal axis. This is the incident ray, angle between the incident ray and normal is the angle of incidence, we write that is I. Similarly, with equal angle, the ray is returned back into the same medium, you know, and we draw the reflected ray. This one is the reflected ray, this one is the reflected ray, and at this angle is the angle of reflection, we write that is R. And here two reflected rays are there, this one is the first reflected ray, this one is the second reflected ray, and two incident rays are there. This is the first incident ray, and this one is the second incident ray. Clear? And in the left side means this is the reflecting side, this is the reflecting surface, and after reflection from this point to this point, both the reflected rays actually meet at a single point. That means image is formed at this point, and for image, this is the height of the image or size of the image, and for height and size of the image we write that is A1 B1. That means image is formed at point A1, object is situated at point A, F is the focus, C is the center of curvature, and P is the pole of the spherical mirror. Clear? Then we write all the measurement in case of a spherical mirror always starting from the point P. P means pole, so that we write PF. First we write PF. Next PA1, we write PA1. Always measurement is starting from point P. Again we write PC. Next PA. Clear? Similarly, above the principal axis, that is AB, we write AB. Similarly, below the principal axis, image is there, that is A1 B1. Clear? And PF. F means focus, distance between pole to the focus, this is the focal length. For focal length, we write the symbol F, small f. PA1, at point A1 image is there, so the distance between pole to the position of the image, that is we write small v. Always we write small v for image distance. Similarly, PC, P to C, C is the center of curvature, and distance between pole to the center of curvature, this is the radius of curvature. For radius of curvature, always we write capital R. Similarly, P to A, at point A, object is there. At point A, object is there. So that P to A, that is the distance of the object. For distance of the object, we write that is U. Clear? Similarly, AB is the height of the object or size of the object. For height or size of the object, we write that is capital O. A1, B1, that is the height of the image or height of the or size of the image. For size of the image, we write that is I. Then which one is positive and which one is negative? And here we can follow the sign convention. And you know the sign convention. These are the rules of the sign convention. You know that is all distance are measured from the pole of the mirror. And here, if distance measured in the same direction as the incident ray, that is positive. If distance measured in the opposite to the direction of the incident ray, that is negative. Same as the incident ray, direction is same as incident ray, that is positive. Direction is opposite to the incident ray, that is negative. Similarly, upward with respect to x-axis or above the x-axis, sign is positive. Above the x-axis, sign is positive. And below the x-axis or downward with respect to the x-axis, sign is negative. 4 sign conventions are there. Clear? And we use this sign convention here. First one, PF. And this is the direction of the incident ray. This one is the direction of the incident ray. This is the direction of the incident ray. Clear? And we measure PF. P to F, not FP. We measure P to F. That means this is the direction of the incident ray, and we measure just in the opposite direction, P to F. So that PF, that is the focal length, and focal length is negative. In place of F, here we write minus F, not plus F. Clear? That means in case of a concave mirror, always focal length is negative. Always focal length is negative, not positive. Similarly, next is PA1, P to A1. We measure from P to A1. PA1, that means this is the direction of the incident ray. Here measurement of the image distance just in the opposite of the direction of the incident ray. So that P to A1, that is also negative. We write that is minus V, not plus V. Clear? And here image is inverted. Inverted means you know, inverted means that is not erect. Inverted means that is not erect. Clear? And here erect means not inverted. Erect means not inverted, and the image is inverted, and this is a real image. Why? Because both the reflected rays actually meet at this point, so that image is a real one and inverted. And in this case, nature of the image is a real and inverted. So that in case of a concave spherical mirror, if image is real and inverted, then image distance is always negative. If image is real, that means in case of a real image of concave spherical mirror, image distance is always negative, that is minus V. Similarly, P to C means P point to C point, and here we measure P to C just like this. P to C just opposite to the direction of the incident ray. Just opposite to the direction of the incident ray, so that here also sign is negative. Similarly, P to A, here measurement is just opposite to the direction of the incident ray, because this is the direction of the incident ray, and measurement is just opposite. P to A, at point A, object is there. For object distance, we write that is U, and here also that is negative. And always object distance is negative. In case of concave mirror or convex mirror, That means in case of a spherical mirror, object distance is always negative. Clear? That means always we write minus u, not plus u. Similarly, a B, this is the height or size of the object, and the object is situated above the principal axis, and above the principal axis means we write that is positive. Clear? And if image is inverted, that is situated below the principal axis, means sign is negative. Clear? That means in case of a inverted image, always sign is negative. And for object height, always object is situated above the principal axis, so that height of the object or size of the object is always positive. Always we write plus O. Always for height of the object we write plus O. If image is real and inverted, always we write sign is minus I. And this is the sign convention. Where the image is a real and inverted in case of a concave spherical mirror. Similarly for convex. Suppose we take a convex mirror. And here inner surface is silver coated. This is the inner surface, because this is the whole sphere, and this is the inner surface of the hollow sphere. And this point is the center of the reflecting surface, because this side is the reflecting surface. And for center of the reflecting surface we write that is P for pole. And a line is passing through the pole and perpendicular to the reflecting surface at pole, so that this line is known as the principal axis. And here, in case of a convex spherical mirror, if we draw the whole sphere, this is the whole sphere, this is the total sphere, so that in this side, center of the sphere is there. That means, suppose this point is the focus of the convex mirror, and this point is the suppose center of curvature of the convex mirror, that is situated in this side. Clear? Then object is situated always in front of the mirror. Object is situated always in front of the mirror. And this one is the object. This is the head of the object. And for object we write always a B. That is the height of the object or size of the object. Clear? Now you draw the image. For image we take two incident ray. This is the first incident ray parallel to the principal axis, and you know after reflection the ray return back into the same medium, and the ray moves along this direction. This is the reflected ray. Clear? Similarly, another incident ray, second incident ray, moves towards the point P, and you know with equal angle the ray is returned back into the same medium. This is the reflected ray. That means this is the angle of incidence and this is the angle of reflection. And here two incident rays are there. This is the first incident ray. This is the second incident ray. For first incident ray, this is the first reflected ray. For second incident ray, this is the second reflected ray. And in this side, distance between both the reflected is gradually increase. That means both are diverge with each other. If both are diverge with each other, both the reflected ray cannot meet with each other in this side. So that we extend both the rays in the backward direction. And if you extend this ray in the backward direction, you know that ray must be passing through the focus. Similarly, if you extend the second reflected ray, both the reflected ray meet at this point. That means this is the position of the image in case of a convex spherical mirror. And you draw the image. This is the image. Always object or image always perpendicular to the principal axis. And this is the head of the image. and for image size we write that is A1 B1, and the image is not inverted. Image is not inverted, so that is a erect one. And these rays are not real rays, these are the imaginary rays. Imaginary rays means we write that is virtual, and the nature of the image we write that is virtual and erect. That is virtual and erect. That means convex spherical mirror always gives virtual and erect image. Always gives virtual and erect image. No real image is there in case of convex mirror, because always reflected rays diverge with each other. If reflected rays diverge with each other, no real image is formed. Always virtual image is there. Clear? Then put the sign convention. First, always measurement is starting from point P, so that we write P in the left hand side. A is there. A means that is the position of the object. We write PA. P to A, that is the object distance. That means here this is the direction of the incident ray. This is the direction of the incident ray, and we measure P to A just in the opposite direction of the incident ray. P to A, this is the direction of the incident ray, measurement is just opposite, so that PA means object distance is negative. We write minus U. That means mirror may be concave or may be convex. That means in case of a spherical mirror, always object distance, if object is a real one, for real object always that is negative. Similarly, next is PA1. At point A1, this is the position of the image, and the measurement is from P to A1, not A1 to P. P to A1, that means in the same direction as the incident ray. So that PA1 we put that is plus, and A1 means that is the position of the image, we write that is V. Because for image distance we write symbol V, small v. Similarly, F, P to F. P to F, F means focus, P to F means that is the focal length. This is the direction of the measurement, P to F, so that is positive, and for focal length we write plus F. Then P to R, we write this point also not R, this point we write that is the C for center of curvature. Clear? Then P to C, PC means the radius of curvature, and here we measure always starting from P to C, that means same direction as the direction of the incident ray, not in the opposite direction, and that is also positive. We write that is plus, and this distance that is the radius. For radius of curvature we write that is R, and these are the measurement on the x-axis. Clear? Or on the principal axis. Now above the principal axis and below the principal axis, and your object is situated above the principal axis, and simply you know above the principal axis means that is plus, and for object height we write O. Very simple. Similarly, below the principal axis means that is negative, but here image is situated above the principal axis, and above the principal axis means for image height we write A1 B1, this one A1 B1, that is also positive. That means in case of a convex mirror, always image is virtual, so that for virtual image sign of the image height, of the image or size of the image, that is positive. So that in case of convex, both object height and image height both are positive, because both are situated above the principal axis. Clear? Once again, this is the sign convention for measuring distance in case of concave and convex mirror. And you also know that, you also know all the points, Clear? These are the rules. Similarly, these are the main points, these are the some points to notes, And we also discussed these points, clear? First point, you also know that for a real object, if object is a real one, if object is real, always object is real. Object distance is always negative. You also know that. Object distance is always negative. Object distance is always negative because this is the object distance. This is the object distance, that is PA. Here you write PA, that is minus U in case of convex. Similarly, in case of concave, you also write PA, that is the object distance, minus U, this distance, P to A. That means object distance is always negative. Object distance in case of spherical mirror, that is always negative, clear? Similarly, if image is real, means that is inverted. If image is real means that is real and inverted, because two types of image are also always there. Two types of image are always there. In case of convex, one type of image is there, that is always virtual and erect. That means convex mirror always produce virtual and erect image. But concave mirror produce two types of image, that may be real inverted or may be virtual and erect in case of concave. If image is real, real means that is inverted, inverted means that is negative, very simple. Inverted means negative, not inverted means positive. Similarly, if image is virtual means that is the not inverted because that is the nature. Nature is virtual and erect. Nature is virtual and erect. That means if image is virtual, that is also erect. Erect means not inverted. Not inverted means you know that is the positive, very simple. Not inverted, positive. Inverted, that is negative. Similarly, focal length. You know, focal length of the concave mirror is always negative. Focal length of the concave mirror, this is the concave mirror. This point is the focus. Focal length, for focal length here we write, that is negative. That means in case of concave, focal length is negative. In case of convex, focal length is positive. You also know that. Same thing. In case of concave, focal length is negative, and in case of convex mirror, focal length is positive. Clear? Similarly, if image is above the principal axis, height is positive. Image is above the principal axis, height is positive. This one. Image is above the principal axis, height is positive. Clear? Similarly, image is below the principal axis. If image is below the principal axis, image height is negative. Image is below the principal axis, means this situation. Image is below the principal axis, here height is negative, that is minus I. Clear? Similarly, last one, you also know that object is always above the principal axis. Always situation is that. Always object is situated above the principal axis, and above the principal axis means object height is always positive. Object height is always positive, and these are the sign conventions for spherical mirror. And in the next class, we will discuss about relation between focal length and radius of curvature of the spherical mirror.